How was your day?
Good.
Good. Sadie, I need you to do me a favor and push this button. It's a stopwatch, okay? I need you to press start. Is the time going? You see it?
Yeah.
Okay, we're going to put this over here and come back to it later, okay? But don't forget about it. So it's the afternoon and you've spent the day doing a ton of things. So how much energy do you have right now?
A ton.
A ton?
A ton.
A ton? Why do you have so much energy? How do you have it?
Because you're sitting in a seat all day.
But wouldn't that mean you don't have a lot of energy? Wouldn't that make you tired?
No.
No. Sitting down gives you a lot of energy?
Yes.
Davey, do you have a lot of energy or a little?
Not.
How do you have a lot of energy? What gave you that energy? Resting gave you energy? Tegan, do you have a lot of energy or a little?
Yes.
How do you have a lot of energy?
Because like eating stuff gives us.
And you just had snacks, didn't you? What'd you have?
I had orange.
And that probably gave you a lot of energy. Well, do you know about other types of energy?
Yeah.
Yeah.
I think ice is energy.
How is ice energy? You don't know?
Energy, you use up energy when you like turn on a light.
Yeah.
Or keep it on for like a long time.
That's called electrical energy. So there's all different types of energy. There's electrical energy, like you said, turning on a light. There's kinetic energy, so in that
It like connects.
there is magnetic energy with the magnets. You know how they pull really close together,
Yeah.
and your hands are shaking because they're moving so close together. And then there's kinetic energy, and that's the energy of moving. So little tiny things have kinetic energy, and then the things such as the world, because it's moving, that has kinetic energy too. And do you know any other types of energy that you can think of? There's chemical energy with chemicals and when they react together. And an example would be like an explosion. So that would be a chemical energy right in front of your eyes. And then what about roadies?
Ears.
And what do your ears help you do?
Here.
Hear sound.
Yeah.
So do you think there might be sound energy?
Yes.
And sound energy is through vibration. So you know when you hit a drum and it vibrates and you hear that vibration?
Yeah.
That's sound energy. So we are going to learn more about thermal energy, energy of heat. So an example of thermal energy would be the sun, because does that give off heat?
Yeah.
So can you think of anything else that would be a thermal energy? Fire energy, because why? What does that give off? Heat, and it makes you what? When you stand next to it and you put your hands, what do your hands
It
do?
makes me like.
Your hands get really, really hot. Can you think of another one? No? Can you think of any, Keegan? That would,
Ball gives like off heat, like when you put your hand here.
And that's an example of two different types of energy. Well, that's cold. That's not heat. But light energy would be an example. A light bulb does give off heat, so that's an example of two different types of energy. So that's pretty good. Now we're going to learn more about thermal energy, and to do so, we are going to use this cootie catcher. You guys have used cootie catchers before, right? You have? I thought you were going to say no. Okay, so I'm going to play with it first, and then you guys are going to take it. So, do you want to pick a number, Sadie? Easy. Go ahead. 2, 3, 4. And can you pick left or right side? And what does that say? And do you want to tell me what heat is?
Energy turns first from a warmer object to a colored.
A cooler one. So can you think of a really warm object? Like the sun, right? We were talking about the sun.
Fire.
And fire. So those are both warm. We'll do the fire. So fire is really warm. So that's an example. And you're standing in front of it and you just came in from playing with the snow and your hands are what? Are they cold? So that's warm energy, the fire, to cold, which is your hands, right? Okay, so that's what heat is. Tegan, can you pick a number?
2.
1, 2. Can you pick left or right side? Which one? Again? Okay, what's this say?
Heat.
And what's heat again?
Energy transferred from a warmer object to.
And can you give me an example again? Even though we just did it. Fire. Okay. And do you want to pick a number now? 1. Sadie, can you pick a side? Oh, I didn't mean to throw that at you. Can you read this? It says thermal
Thermal energy.
Good. And can you read what that says?
Energy that comes from here.
So, we talked about energy that comes from heat. So with the example of the fire, the energy is coming from the fire, right? Sadie, can you pick a number?
3.
1, 2, 3. Can you pick one? Says joules. Can you read what that is? So the amount of thermal energy. So you know how we measure things, like you can weigh things? Well, to determine thermal energy, you do that with joules. Can you say joules? Not joules like earrings you wear. It's a different type of joules. It's a measurement. So what did we say joules were?
Different kind of measurement.
To measure thermal energy. Can you pick a number? I don't think we've done all the ones in there yet. 1, 2. Can you pick one? Can you read to me what that says? Conductor. And can you tell me what it says?
Something that lets heat move through.
So, something that lets heat move through it. So that's how the heat gets to the next thing, right?
Yes.
So, an example. We'll get to an example in a second. Make sure we get everything. Tegan, you want to pick a number?
3.
1, 2, 3. Sadie, do you want to pick one? Pick a side. This one. And does that say thermal energy? Do you remember what thermal energy is? Or do you need help?
Energy that comes from heat.
Energy that comes from heat. Do you remember that? Did you remember that? Sadie, do you want to take this? And you can do it now, and you can quiz them and see. So pick a number, Tegan. Oh, careful. So go 1, 2, 3, 4. And do you want to pick one? And which one did she pick, Tegan?
Conductor.
And Sadie, can you tell us what a conductor is? Do you remember?
Something that lets heat move
Yeah. So I told you go ahead, Tegan. You can go ahead. You can already turn it. We'll all do it once, okay? Here you go. Yeah, 2 hands. So 2 fingers on one side and 2 on the other. And you open it. 1, 2.
Take a number. 1, 2, 3.
Sadie, can you pick a side in there? What does that say? Joules. And who remembers what joules is? Before we do it, what do you think? You're looking.
I'm not gonna say it.
What do you think it was?
Joules is a measure.
A measure of what? Thermal
Heat.
Thermal energy. Everyone say thermal energy.
Thermal
3 times.
Thermal energy. Thermal energy. Thermal energy.
Good. Try to remember that. Go ahead. Your turn. Be careful. Jeez. There you go.
Cool.
Which one? Heat. Who remembers what heat is before we open it? Do you have an idea in your head? Yeah?
Heat is like
Do you want to help her out and read the definition to her?
warm energy transferred from a warmer object to a
So it goes warm to cold. So think about that
cold
fire.
to warm.
No, warm to cold. Hot to cold.
Oh.
Yeah? Because we're passing the heat along. So, I have some questions for you. Can anyone tell me what this is? Do you see what that is?
It's a pot on the stove.
And what's in there?
Water.
Water. And what happens when you put water on?
It boils.
It boils. So this is a what? A pot of
Pot of
boiling water. And is that water, what always happens when your mom boils pasta water? Do you go touch it?
No.
Because it's really hot, right?
Yeah.
So that is our heat. So there's a lot of heat in our pasta. I mean, in our water, sorry.
And that's
And what's this? Pasta. And it's pretty cold, right?
Yeah.
When you can touch pasta in your hand when it's not cooked before you put it in. Yeah. It's just a pretty average temperature, right? So it's not hot. And then what's this?
Spaghetti getting boiled.
So when we're so we have our pot of hot water, right? Our boiling water. and we're putting in the noodles into the water, the noodles are acting as a conductor. Can you say conductor? And what did we say a conductor was?
Something that lets heat move through it.
So we're putting our pasta noodles into our boiling water, and the heat is moving through it, and it's gonna cool down that water temperature. You know, when you first dump it in, and it's gonna put some of that heat in there. So our
Like
cold,
passing on.
exactly. So our cold noodles are gonna warm up now. So our hot water is passing it on the heat to a cooler object, which is the noodles, right? So another way to do that, I want you to look at these. What are these?
Hands.
And feel your hand. Are they cold? Are they hot right now?
They are
Medium. Medium. And then, can you tell me what these are?
Ice cubes.
And what are ice cubes?
They're
hot.
ice. They're water. Ice frozen.
But temperature-wise, hot, cold,
Cold.
they're freezing, and your hands in comparison are pretty hot, right? So we are going to act. See these? They're going to be conductors of heat. So your warm hands, if they're not warm, start rubbing them together and make them warm just in case. Blow on them, because you want to get your hands really warm, because your goal is we're gonna put ice into a bag and melt that ice.
Oh my god.
Okay? So you need to warm those hands up, and they're gonna act as what word?
Conductors.
And we're gonna pass that heat along, right? So we're gonna put an ice cube in everyone's bag, but you can't start melting your ice cube till I say go. Okay? We're gonna time it. So you wanna go as fast as you can. Warming up your hands, getting ready. Thanks for grabbing that for me. Tia, are your hands warm? Are they warming up? Are you sure? Really hot? Well, this ice cube is pretty cold. So, you're going to use your hands in any way possible because they're what? Conductors. And they're going to move what? Their
Heat.
and we're going to transfer that heat. So, everyone pick up your bags of ice and hold them in your hands. Count. I'm going to put my timer on. And on the count of 10, we can go. Ready? Count with me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Melt your ice cube. Think about different ways if you use a blow on it. You need to just translate. You need a conductor. Try to use your hands. If you need to take a break and rub your hands back together. Pick it up. Rub your hands back together. If your hands need a little break, you can rub them back together, get them all nice and warm, and then translate that and put that heat back. Melt them, melt them, melt them! Make sure you're using your hands because those are conductors. So only you be using your hands to melt it. So if you need to put your ice cube down and rub your hands back together. Careful, I think it's here. And you want to stop and look at your ice cube because you need to make sure it's melted. Is it melting? Does everyone see water in theirs?
Yeah.
Yeah? Keep melting. Tell me when it's melted. Tell me.
Where it went.
Is it all gone?
Okay, here. Ugh. Mine's all gone. No,
It's all
not.
gone?
Oh, yeah, no.
Keep melting. Did you get it lost in the bag? Is it all gone? Let me see yours. How's it going? Is it melting? Kinda. Rub those hands together.
I don't know where it is. It's so hard.
Okay, Tegan, you're done.
I can't find it. Where is it?
You're all done.
I got there. Is there?
Yep, you're all done.
Right here. Is it?
Nope, you're all done.
My
You
hands
melted
are
it.
freezing.
It took you 3 minutes and 16 seconds.
Yeah, 3 minutes and 16 seconds.
So,
Oh my
can
god,
you
mine's gone.
keep melting? No, let me see. I see ice
Oh,
cube.
yeah.
Let me see. Almost done. Keep melting. So on this piece of paper, you want to write your name in 3 minutes and 16 seconds.
Okay, mine's done.
It's all done? I see ice cube right there. Keep melting.
Mine's done.
You're all done?
Oh, wait, no. Can you write my last name?
Tiny bit. Sure.
Is mine gone? Mine's
Almost.
gone.
You only have a little bit. You're all done? M-I-N-U-T-E-S.
Good? Yeah, mine's done.
16
Good.
Done?
Mine's done. Mine's done.
And here you go. And here you go. Just in case your hands got wet, they're all done.
They did get it.
So did you feel that heat moving to the ice?
Yeah.
Here.
It's all like
Now,
gone.
okay, so let's hold up, everyone hold up your bags. And look at, we went from an ice, here, we'll look at Sadie's bag.
Ah, it's so
We
cool.
went from a whole ice cube, remember what it started looking like? And now look at it.
Mine hit down.
If that's okay.
It looked like this.
It did look like
Now
this.
it's
Look at what happened. And why do you think that happened?
because we were giving it heat, and ice needs to stay cold to stay like in its shape. So, but we gave it hot heat to make it like
Mm-hmm.
melt.
And we did give it heat. And what did we say heat was? Do you remember?
Heat,
Um,
and
so-
they're
some-
being transformed from a warmer object to a
another.
cooler one.
So how do we move that heat?
Like from our hands, example, like we move that heat by rubbing.
With a conductor. Good job.
Yeah.
And how did we keep that heat going?
With like rubbing our hands together.
Keep it
So
with
with heat.
Mm-hmm. So we had to keep rubbing them together, and I saw you blowing on your hands.
I did.
Yeah, to make sure they were keep moving.
Not
Now, so Sadie, can you tell me if this is all water? Can you tell me how long we've gone so far? 20.
20 minutes.
And how many seconds, Stevie?
32.
Is that a long time? Is that a long amount of time? But think about it. How long did it take you to melt your ice cube with your hands?
3 minutes and 59 seconds.
59. And think that's taken 20 minutes just sitting in the sun. So that tells us that there's different types of conductors, right? Because we talked about, that's okay, it's fine with us. We talked about how the sun has heat, right? And we talked about how our hands have heat, right? So there's different conductors. So they can pass the heat quickly or slow.
Like ice.
So we're going to do our math problems one by one. So Tegan, do you want to go first? We're going to see the difference in between the sun melting an ice cube and how fast it took your hands. So we're going to see the difference in time. So, can you do this? 44 minus 16.
This
21 minus 3. 21, 20, 19, 3. So how much of a difference in between you melted it in 3 minutes and 16 seconds and the sun took 21 minutes and 14 seconds. So how long was the difference?
18 minutes and 10 seconds.
Good. And I'm going to pass out this quiz, and all the questions are going to come from what we did earlier today, okay?
Okay.
So,
Are we all going to
you all are going to do it together, and I'm going to give it to you, and you're going to turn it around. Mm-hmm. And you're going to put on the ground. I didn't say pick it up yet. How about you guys hold on. Hold on. And we are going to take the quiz, okay? So you can turn it over. Okay? And here you go. You can see. And Tegan, next question.
Ice cube melts using using thermal energy.
Do you guys agree with her?
Yeah.
Go ahead and highlight it. Sadie, next question.
What is a conductor?
Read it out loud.
Anything that allows the thermal energy to move through it easily. Something that blocks thermal energy. I think A.
A. Do you guys agree with her?
Yes. Yeah.
Go ahead and highlight.
I'm always getting the short ones to highlight. This is not a short one.
There's a lot of answers to choose from.
What? Wait, what?
Here, the next question. Do you want to do it?
What is an example of a conductor?
And what does it say?
Circled all that apply.
So, what are they?
Your hands?
Is that one?
Yes. Yes. Circle it. So circle them.
You can just highlight them, that's fine.
A light bulb.
Do you think that's a conductor?
No.
No. What about the next one?
Cookie,
No. No way. Okay, next one, Tegan.
Which is not a type of energy.
Read them.
Sound energy, chemical energy, cloud energy. Cloud energy.
Did we talk about the other two today?
Yeah.
And do you remember what we said sound energy was? What
Sound energy was like something that it's like a drum. It's like a drum. It
the
like
vibration from the drum? Good.
My turn.
Yep, what's the next question, Sadie?
It says where? It says what does that say?
That's the
Oh.
question.
When you melt the ice cube, what is the energy transformed from your hands to ice?
Was it?
Mm.
Did the energy go from your hands to the ice?
Yes.
Last question. You guys are doing a good job on this quiz.
What type of energy melted the ice cubes? Thermal energy.
You sure?
Yeah.
Positive?
Yes. Yes.
Go ahead and highlight it. I'm going to have to give you guys 100, so high five.